Hi guys, so today we're talking about day 3. We're talking about special cases when you multiply them, and we're going to start factoring out GCF, which is also known as the greatest common factors. Okay, so let's go ahead and get started. So special cases, we have the square of a binomial. Things are popping up left and right. Square of a binomial, which is a plus b, so some number plus some number squared. Okay. When it's the sum of the square, like when it's addition, that will give us a certain kind of answer, and it'll always look very similar to each other than like the actual numbers. Okay, and then when we have the product of the sum and difference of a binomial, sorry, I got distracted. Yeah, the product of the sum and difference of a binomial, where we have a number plus another number times that same first number minus that other number. Okay, so both addition and subtraction come into play. Okay, so here is what it'll look like. This is the special case of a square of binomial. When you have a plus b squared, comes out to be like, this is what it'll look like. It'll be a, it really, when you expand it out, it comes out to be a plus b times a plus b. So when you do FOIL, you actually end up getting a squared plus ab plus ab plus b squared. So those ab's combine together to make 2ab. Okay, so it'll be twice the product of the first and last number, and then the squares of the two numbers in the front and back. So that's why it comes out to be special. So, but that's what, if you memorize this, you are more than welcome to go ahead and plug in those numbers and then simplify it that way. But if you don't want to memorize it and you need to expand it first, that's fine. This is not about distributing the 2 into the a into the b though, because it is addition, not multiplication. You can only distribute that exponent if they're being multiplied together. Okay, so it's about expanding out that binomial and then doing the math that way. Okay, so here's an example, and this is the one I want you to try on your own. You have x plus 3 squared. Okay, here's my hint though. All right, write it out like this, expand it out. So, and then just go ahead and multiply it. You can use FOIL. I use FOIL for my example, so I'll be showing you that when I go over the answer. You can use the shortcut now if you want. You can use Punnett square. You can use distributive property. Whatever works for you. And then we'll go over the answer in a few minutes. Okay, so pause the video. When you come back, we'll start going over the answers. Okay, so if you multiplied you just want to stick to the normal multiplication because that's what you're comfortable with, go ahead. I went ahead and did FOIL. So for the first ones, I multiplied the first two numbers in the binomials, which was x times x giving me x squared. Outer was x times 3, so this x times this 3 gives me 3x. Inner, same thing as 3 times x, so this 3 times this x gives me 3x again. Last is going to be the 3's, so 3 times 3 gives me 9. I don't know why all this stuff is over here. So I can write all these terms out. I get x squared plus 3x plus 3x plus 9, which I go ahead and simplify the like terms. There we go. And I get 6x in the middle. That's my answer. Now, if you decided to go the shortcut method, you would have saved time, that's for sure. So if you look at it, this is our a, the x is a, and the 3 is your b. Okay? So the shortcut said a squared. So if our a is x, we just need to write x squared. Plus 2 times a times b, or b times a, whatever you want to do. Doesn't matter. So 2 times 3 times x, that'll actually simplify to be 6x, just like ours. And then the last one was b squared. So the b is 3 squared, which we can do is 9. So we go ahead and simplify it. 2 times 3 times x will give me 6x. 3 squared is 9, x squared is fine. It gives us the same answer, okay? But it's a lot shorter. So whatever you want to do for it, that's up to you, okay? Let's do the product of the sum and difference of a binomial. This actually comes out to be a squared minus b squared. So the first number minus the second number squared, okay? And the reason it comes out to be because when you do FOIL, it actually comes out to be plus AB minus AB in the middle, which will cancel each other out. Okay? So let's go ahead and do this. So here's your example, x plus 5 times x minus 5. Am I doing this right? Yeah, sorry. So, again, you can do it FOIL if you want. You can do Punnett square, whatever makes you comfortable. I'm going to show it to you the shortcut way and the FOIL way, because that's the stuff I already had done. So, when you come back, we'll go over the answer, okay? Alright, go ahead and pause the video, and I'll see you in a few minutes. Okay, so let's go ahead and start with the FOIL way. So I'm going to multiply the first two terms, the x and the x, and that's my f, so it gives me x squared. Outers is x and the negative 5, which will give me negative 5x. Inners is the 5 and the x, so it gives me 5x. And the last is the 5 and the negative 5, giving me negative 25. Put those together, simplify the x, the negative 5x and the 5x. They cancel each other out, giving me x squared minus 25. So again, this is what b squared is. So if we look at it, a, b, a, b. So a is our x, b is our 5, and they just have different signs in between. If we plug it in, a squared minus b squared, simplify it, negative x squared minus 25, same answer. Okay? Again, shortcut. With any shortcut, there's possibilities for mistakes because you don't know the stuff as well as like all the work and the steps. More steps, you're able to catch yourself, so just be careful with that. Okay? So if you have any questions on these special cases, just write it down. Now, they're special cases because it's a shortcut. Doesn't mean you can't solve it the normal way anymore. Like, you can always solve it the normal way. With FOIL or a Punnett square, just straight up distributing. It's up to you. Alright, next we're going to do is factoring out a GCF. So first thing you need to know is what is a GCF. GCF is the greatest common factor between two terms. Okay? So let's go ahead and factor a couple of numbers. Let's find the greatest common factor between 28 and 42. Now, when you do this, when you're trying to figure out factors, you're trying to come up with the numbers that are divisible by them. Like, what numbers can you multiply together to get 28? So, 1 and 28 are both factors. 2 and 14 will give you 28. 4 and 7 will give you 28. But that's it. Well, yeah, factors, not multiples. Yeah, I'm doing factors, sorry. So, we get that. Same thing with 42, you come up with numbers. You get 1 and 42 will multiply to 42. 2 and 21. 3 and 14. 6 and 7. Okay, so once you write out all the factors, you're going to look for the biggest one they have in common. So they have 1 in common, 2 in common, 7 in common, 14 in common. But it looks like 14 is the biggest number. So that's your greatest common factor between the two, is 14. Okay? So that's what we're going to do with polynomials. So here's your example. I did this as an example, right? Yeah, not as a try your own. So we have negative 6x to the fourth, 18x to the third, and negative 16x squared. What do all three of these have in common? Because what we're basically doing is undoing distributive property. What got distributed to all three that we can take out? Well, all three are integers. Like, oh, they're integers. They're all even numbers, though. So they're actually all divisible by a 2. Okay? Now, whenever there's a negative out front, we don't like that. So if we can get rid of that negative, we're going to go ahead and do it. So my question is, can we take out a negative 2? Are they all divisible by negative 2? Yes, they are. So we can take out that negative 2 from the front, and that will change the numbers. So divide negative 6 by 2, we get 3. Divide 18 by negative 2, we get negative 9. Divide negative 16 by negative 2, we get 8. Okay? So, and factoring is just straight up division. Okay? Now let's look at the x's. Do they have any x's in common? Yeah, they're all x's. But how many they have in common is what we're going to look at for variables. So this first term has 4 x's, this one has 3, this one has 2. What's the most that we can take away from all of them? Is 2. Okay, so we're going to take the x squared away from all of them, and then we just divide, which is basically subtracting the exponents. So we take away 2 from them, we're only going to have 2 x's here, so x squared left. We take away 2 here, 3 minus 2 gives us 1. Take away 2 here, 2 minus 2 is 0, so nothing left. So we just factored out negative 2x squared, leaving us with the 3x squared minus 9x plus 8. And that would be our final answer. So we factored out the greatest common factor. We basically just factored out a monomial from a trinomial. Okay? And we're going to do more with factoring as we go on, but this is all we need to worry about right now, is factoring out that monomial. Okay? So that's it for the video. If you have any questions, please write them down. I will see you next time. And yeah, bye!